Most people affected by diabetes are required to monitor their blood glucose level. This normally involves drawing blood from the person's body. Even more scary, you're required to do this between 8 to 10 times in a day. And this is quite an invasive approach. So as you can imagine, you can surely appreciate the level of stress that's involved. And as a result as well, this can affect someone's well-being. It can affect the way you live your life. In addition to this, diabetes can also become very costly over time. And this can be due to two factors mainly. One, you have to continuously buy the strip that's normally used during an invasive approach method to draw the blood. And in addition to this, poor management can also occur. As you can imagine, if you have to draw blood 8 to 10 times in a day, you might be less inclined to do this. And as a result, this can lead to poor management of your blood glucose level. And because of this can lead to other health complications. So currently in the world, there's close to 500 million people that are affected by diabetes. And here in the UK, the NHS allocates 10% of its budget just to diabetics alone. And these values are projected to increase by the year 2040. My name is Ade, and today I'm going to be discussing with you the work that I've been doing with metamaterial as part of my fellowship project over the past 6 weeks in predicting blood glucose level. So metamaterial, I've recently in the process of developing GlucoWise. GlucoWise is a non-invasive device that can be used to measure glucose concentration level in people affected with diabetes. And this typically works using two types of sensors, so radio frequency and near infrared. So what's the advantage of GlucoWise? Well, the first thing being it's non-invasive. So this is very good. So, the people don't have to go through all this pain. In addition, you can also measure the glucose concentration level continuously. So you can measure as often as much as you like. And in addition, also, this method is very cost efficient and is very convenient because you can measure your blood glucose level under different environment, for instance, where you're driving, which is something you can't do with the invasive approach. So the question that metamaterial are interested in answering is these two main points here. So how good are the two sensors combined at predicting blood glucose level? So this is the radio frequency and the near infrared. And the other question is, how many parameters do they actually need to make a good prediction? So how many numbers of features do they actually need to make a good prediction of the glucose concentration level? So as I mentioned, the data that we have is the radio frequency and the near infrared. And what we did was to combine these two data together and then perform machine learning primarily on each individual one. So the radio frequency on its own, the near infrared, and then the combination of both, and see which one actually gives you a better prediction. So to put this more broadly, so what we have is a very high dimensional data set because we have very low samples and loads of features. And the aim is to apply machine learning to this to get two main outputs. First, the feature importance. So what features are the most important in terms of making a prediction? And also very important is actually what is the level of prediction accuracy that we can get in terms of determining the glucose concentration level. So the algorithm of choice that I used was the random forest, mainly for two reasons. One being the fact that it gives you information on the feature importance. And also it's very adequate for small sample size data, which is what we have in this work. So how well did we do in terms of the prediction? So we quantify this by actually looking at the error. So here we can see for the radio frequency, we had an estimated error of 48%. So when we use the near infrared, we were able to reduce this to 44%. And using a combination of both, we got this to 38%, which is really good. And overall, there's a 6% reduction in error compared to when we used both method compared to just the near infrared radiation. So relating to the most important features that actually makes the contribution to the prediction. So out of roughly around over 300 features that were present in the measurements, we found out that only 7% of this, around 18, was actually useful in terms of making the prediction. So this is really good. So what does all of this mean for metamaterial? Well, the first thing is we're able to actually give them the information of where to concentrate their efforts. So for instance, we know that, okay, this is the range of measurements that you need to be taken, because these are the only areas that actually contribute to the glucose prediction. That's one. As a result of this as well, this actually improves their processing time. So we can reduce the processing time of them acquiring your data by more than a half. And as a result of this as well, it's also cost efficient because you don't have to spend a lot of money on buying sensors for wavelength ranges that are actually not useful. And hopefully, as a result of this work, it can accelerate the process of metamaterial, providing a non-invasive way of actually measuring the blood glucose level of patients or people affected by diabetes. Thank you very much for listening.